So in an earlier lecture in the first week when we introduced the interpreter ghci, we said that you cannot define new functions directly in ghci, unlike say in Python, and you must create a separate Haskell file with extension .hs and load it into ghci. It turns out that this is not entirely accurate. So in order to use functions definitions in ghci, we need to learn a little bit more about Haskell. So we have seen the use of the word where in order to specify local definitions in functions, right? So we can define a function in terms of some local definition and use these definitions in the function. Now, an equivalent way of doing this is to use an expression called let. So we can, instead of using where, we can say let diff x be x2 minus x1, diff y be y2 minus y1 in this definition, right? So these are seemingly two equivalent ways to write it. We have looked at where so far, we have not seen let. So let something in something is a Haskell expression. It's like if something, then something, else something, which is also a Haskell expression. It can be used wherever an expression is allowed. At the level at which we are using Haskell, there is no significant difference between let and where, which is why we have used where so far. The distinction is minor for us, but actually because let is a full-fledged Haskell expression and where is not, they are not equivalent in more complicated contexts, as we may see when we go along. If you are curious, you can look up this link to find out some ways in which let differs from where. Now at this moment, what is relevant for us is that we can use let inside ghci to define functions on the fly. At a basic level, we can use let to define single line values. So we can write something like let square of x equal to x star x, and now square will be available within ghci. So therefore it is definitely possible to actually define functions indirectly in ghci, not exactly the way you would do it outside in a Haskell file, but by using let. Of course, this is a single line definition. What if we want a multiple line definition, like say factorial, which is defined separately for 0 and n? So we can use this notation colon open brace and colon close brace to enclose a multiple line definition. So if we say colon open brace, notice that you will find a slight change in the prompt that ghci gives you. Instead of the greater than in, it will give you something else, perhaps a pipe symbol like this, until you put a close brace, and then the next line will return back to the usual prompt. And in between, you can write a multiple line let. For example, we can say something like let fact into int be the function where fact of n, if n is less than 1, is 1. Otherwise, it's n times fact n minus 1. So here, let us actually do this to verify that this works. So we say ghci. Then we can say let square x equal to x star x. Now if we say square of 8, for instance, we get 64. If we say square of 16, we get 256, and so on. Now if we want a multi-line definition, we can, the prompt changes. Now we can say let fact int to int be given by fact n such that n is less than 1 is equal to 1. Otherwise is equal to n times fact of n minus 1. Okay, and then we close this multi-line definition, we get back to the old point. Now we say what is factorial of 7, we get 5040. We say what is factorial of minus 2, we get 1, and so on. Right? So we can use let with the open brace, close brace if necessary to define functions in ghci indirectly, not exactly the same way we do it in the Haskell file which we source through the load function, but effectively we can write functions on the fly. So to summarize, we cannot directly define functions within ghci unlike Python. In Python, the same def command which you use to define functions in a file is exactly what you use in the interpreter. And in Haskell, you have to use let, perhaps with this multi-line colon open brace, colon close brace. And I would like to thank Oleg Sugulski from Odessa for pointing this out on the discussion forum.